learning objectives. In this chapter, the user would learn the following in detail. Need for object-oriented programming, procedural languages, the object-oriented approach, advantages of object-oriented programming, characteristics of object-oriented languages, objects, classes, inheritance, reusability, new data types, polymorphism, and overloading. Characteristics of object-oriented languages. Below are some of the concepts used extensively in object-oriented programming: objects, classes, data abstraction and encapsulation, inheritance, polymorphism, dynamic binding, message passing. Objects. Objects are the basic runtime entities in an object-oriented system. They may represent a person, a place, a bank account, a table of data, or any item that the program has to handle. They may also represent user-defined data such as vectors, time, and a list. Programming problem is analyzed in terms of objects and the nature of communication between them. Program objects should be chosen such that they match closely with the real-world objects. Objects take up space in the memory and have an associated address like a record in Pascal or a structure in C. When a program is executed, the objects interact by sending messages to one another. Each object contains data and code to manipulate data. Objects can interact without having to know details of each other's data or code. It is sufficient to know the type of message accepted and the type of response returned by the objects. Classes. The entire set of data and code of an object can be made a user-defined data type with the help of class. In fact, objects are variables of the type class. Once a class has been defined, we can create any number of objects belonging to that class. Each object is associated with the data of type class with which they are created. A class is a collection of objects similar types. For example, banana, grapes, and guava are members of class fruit. Classes are user-defined that types and behave like the built-in types of a programming language. The syntax used to create an object is not different than the syntax used to create an integer object in C. If fruit has been defined as a class, then the statement fruit mango will create an object mango belonging to the class fruit. Inheritance. Inheritance is the process by which objects of one class acquired the properties of objects of another classes. It supports the concept of hierarchical classification. For example, the bird, thou is a part of class flying bird, which is again a part of the class bird. The principle behind this sort of division is that each derived class shares common characteristics with the class from which it is derived. In OOP, the concept of inheritance provides the idea of reusability. This means that we can add additional features to an existing class without modifying it. This is possible by deriving a new class from the existing one. The new class will have the combined feature of both the classes. The real appeal and power of the inheritance mechanism is that it allows the programmer to reuse a class that is almost but not exactly what he wants and to tailor the class in such a way that it does not introduce any undesirable side effects into the rest of classes. Polymorphism and overloading. Polymorphism. Polymorphism is another important OOP concept. Polymorphism, a Greek term, means the ability to take more than one form. An operation may exhibit different behavior in different instances. The behavior depends upon the types of data used in the operation. For example, consider the operation of addition for two numbers. The operation will generate a sum if the operands are strings. Then the operation would produce a third string by concatenation. The process of making an operator to exhibit different behaviors in different instances is known as operator overloading. A single function name can be used to handle different number and different types of argument. This is something similar to a particular word having several different meanings depending upon the context. Using a single function name to perform different type of task is known as function overloading. Polymorphism plays an important role in allowing objects having different internal structures to share the same external interface. This means that a general class of operations may be accessed in the same manner even though specific action associated with each operation may differ. Polymorphism is extensively used in implementing inheritance. Overloading. Overloading is one type of polymorphism. It allows an object to have different meanings depending on its context. When an existing operator or function begins to operate on new data type or class, it is understood to be overloaded. Reusability. Reusability refers to the ability for multiple programmers to use the same written and debugged existing class of data. This is a time-saving device and adds code efficiency to the language. Additionally, the programmer can incorporate new features to the existing class, further developing the application and allowing users to achieve increased performance. This time-saving feature optimizes code, helps in gaining secured applications, and facilitates easy maintenance on the application. Data types. A data type determines the type and operations that can be performed on the data. C++ provides various data types and each data type is represented differently within the computer's memory. The various data types provided by C++ are built-in data types, derived data types, user-defined data types. Built-in data types. The basic fundamental data types provided by C++ are integral, floating point, and void data type. Among these data types, the integral and floating point data types can be preceded by several type modifiers. These modifiers, also known as type qualifiers, are the keywords that alter either size or range or both of the data types. The various modifiers are short, long, signed, and unsigned. By default, the modifier is signed. In addition to these basic data types, ANSI, C++ has introduced two more data types, namely bool and wchar_t. Integral data type. The integral data type is used to store integers and includes character and integer data types. Character. Characters refer to the alphabet, numbers, and other characters such as flower bracket, @ etc. defined in the ASCII character set. In C++, the character data type is also treated as an integer data type, as the characters are internally stored as integers that range in value from -128 to 127. The character data type occupies 1 byte of memory, that is, it holds only one character at a time. The modifiers that can precede character are signed and unsigned. The various character data types with their size and range are listed in table. Character data types has 3 columns: type, size in bytes, range. Types: character, signed character, unsigned character, size in bytes, 1, 1, 1. Range: -128 to 127, -128 to 127, then 0 to 256, that means 256. Integer. Numbers without the fractional part represent integer data. In C++, the integer data type is used to store integers such as 4, 42, 5233, -32, -745. Thus, it cannot store numbers such as 4.28, -62.533. The various integer data types with their size and range are listed in table. Integer data types is shown in the table. Floating point data types. A floating point data type is used to store real numbers such as 3.28, 64.75565, 8.01, -24.53. This data type includes float and double data types. The various floating point data types with their size and range are listed in the table. Floating point data types is shown in the table. Void. The void data type is used for specifying an empty parameter list to a function and a return type for a function. When void is used to specify an empty parameter list, it indicates that a function does not take any arguments, and when it is used as a return type for a function, it indicates that a function does not return any value. For void, no memory is allocated, and hence it cannot store anything. As a result, void cannot be used to declare simple variables. However, it can be used to declare generic pointers. Bool and W character _t. The bool1 data type can hold only Boolean values, that is, either true or false, where true represents 1 and false represents 0. It requires only 1 bit of storage. However, it is stored as an integer in the memory. Thus, it is also considered as an integral data type. The bool data type is most commonly used for expressing the results of logical operations performed on the data. It is also used as a return type of a function, indicating the success or the failure of the function. Derived data types. Data types that are derived from the built-in data types are known as derived data types. The various derived data types provided by C++ are arrays, junctions, references, and pointers. Array. An array is a set of elements of the same data type that are referred to by the same name. All the elements in an array are stored at contiguous, one after another, memory locations, and each element is accessed by a unique index or subscript value. The subscript value indicates the position of an element in an array. Function. A function is a self-contained program segment that carries out a specific well-defined task. In C++, every program contains one or more functions which can be invoked from other parts of a program if required. Reference. A reference is an alternative name for a variable. That is, a reference is an alias for a variable in a program. A variable and its reference can be used interchangeably in a program as both refer to the same memory location. Hence, Changes made to any of them, say a variable, are reflected in the other on a reference. Pointer. A pointer is a variable that can store the memory address of another variable. Pointers allow to use the memory dynamically. That is, with the help of pointers, memory can be allocated or deallocated to the variables at runtime, thus making a program more efficient. User-defined data types. Various user-defined data types provided by C++ are structures, unions, enumerations, and classes. Structure, union, and class. Structure and union are the significant features of C language. Structure and union provide a way to group similar or dissimilar data types referred to by a single name. However, C++ has extended the concept of structure and union by incorporating some new features in these data types to support object-oriented programming. C++ offers a new user-defined data type known as class, which forms the basis of object-oriented programming. A class acts as a template which defines the data and functions that are included in an object of a class. Classes are declared using the keyword class. Once a class has been declared, its object can be easily created. Enumeration. An enumeration is a set of named integer constants that specify all the permissible values that can be assigned to enumeration variables. These set of permissible values are known as enumerators. For example, consider this statement. Need for object-oriented programming. Object Database Management Systems, OODB, MS, S. Also variously referred to as object-oriented databases, OODBS. Object-oriented database management systems, OODBMS, or next generation database systems, try to address some of the shortcomings of existing relational database technology. Briefly, some of these shortcomings are lack of expressive power. The only data structure, aggregate or object in the relational model is the table. This reduces all data to flat two-dimensional form, with relationships between tables being dynamically reimposed at runtime. The lack of a facility for establishing relationships between tables at design time is probably the main backward step from the structured database. Simple data types. To support next generation applications, a richer set of data types is required. Example, arrays list multimedia data types. Loss of data protection. Most OODBMS support simple data types. Example, integer, character. Many programming languages, however, enable new enumerator types to be defined. When these enumerator types need to be mapped to the database types, data protection is lost. Impedance mismatch. Mapping data structures between programs and the database can account for a considerable amount of code. These are several reasons why this mapping is necessary. Firstly, SQL is relationally complete. It supports the operations select, project, and join, but it is computationally incomplete in the sense of a programming language such as C, Pascal, etc. Secondly, computer programming languages such as C, Pascal, etc. are procedural and record-oriented, whilst database query languages such as SQL are more declarative and set-off oriented. Thirdly, computer programming languages support rich data types, example arrays, whilst SQL is a closed language operating on two-dimensional tables with simple types, example integer character. This mix of paradigms, SQL and OST language results in this impedance mismatch. Performance. OODBMS have been unable to provide the necessary performance for applications with complex relationships and multi-way joins. By its very nature, the relational model flattens entities. Putting these entities together in a meaningful way requires joining and sorting. These operations compete for being the slowest in relational systems. In addition, commercial language optimizers are often unable to cope effectively with queries involving large numbers of joins, which has resulted in static binding strategies being developed by some relational database vendors. Procedural language. Procedure-oriented programming. In the procedure-oriented approach, the problem is viewed as the sequence of things to be done, such as reading, calculating and printing, such as COBOL, Fortran and C. The primary focus is on functions. The technique of hierarchical decomposition has been used to specify the task to be completed for solving a problem. Procedure-oriented programming basically consists of writing a list of instructions for the computer to follow and organizing these instructions into groups known as functions. We normally use flowcharts to organize these actions and represents the flow of control from one action to another. In a multi-function program, many important data items are placed as global so that may be accessed by all the functions. Each function may have its own local data. Global data are more vulnerable to an inadvertent change by a function. In a large program, it is very difficult to identify what data is used by which function. In case we need to revise an external data structure, we also need to revise all functions that access the data. This provides an opportunity for bugs to creep in. Another serious drawback with the procedural approach is that we do not model real-world problems very well. This is because functions are action-oriented and do not really corresponding to the element of the problem. Some characteristics exhibited by procedure-oriented programming are: emphasis is on doing things, algorithms. Large programs are divided into smaller programs known as functions. Most of the functions share global data. Data move openly around the system from function to function. Functions transform data from one form to another. Employs top-down approach in program design. The object-oriented approach. The major motivating factor is the invention of object-oriented approach is to remove some of the flaws encountered in the procedural approach. OOP treats data as a critical element in the program development and does not allow it to flow freely around the system. It ties data more closely to the function that operate on it and protects it from accidental modification from outside function. OOP allows decomposition of a problem into a number of entities called objects and then builds data and function around these objects. The data of an object can be accessed only by the function associated with that object. However, function of one object can access the function of other objects. Some of the features of object-oriented programming are: emphasis is on data rather than procedure. Programs are divided into what are known as objects. Data structures are designed such that they characterize the objects. Functions that operate on the data of an object are ties together in the data structure. Data is hidden and cannot be accessed by external function. Objects may communicate with each other through function. New data and functions can be easily added whenever necessary. Follows bottom-up approach in program design. Object-oriented programming is the most recent concept among programming paradigms and still means different things to different people. Advantages of object-oriented programming. Object-oriented programming offers several benefits to both the program designer and the user. Object orientation technology promises greater programmer productivity, better quality of software and lesser maintenance cost. The principal advantages are, through inheritance, we can eliminate redundant code, extend the use of existing classes. We can build programs from the standard working modules that communicate with one another. Rather than having to start writing the code from start, this leads to saving of development time and higher productivity. The principle of data hiding helps the programmer to build secure program that cannot be invaded by code in other parts of programs. It is possible to have multiple instances of an object to coexist without any interference. It is possible to map objects in the problem domain to those in the program. It is easy to partition the work in a project based on objects. The data-centered design approach enables us to capture more detail of a model can implemental form. Object-oriented system can be easily upgraded from small to large system. Message passing techniques for communication between objects makes to interface descriptions with external systems much simpler. Software complexity can be easily managed. Conclusion. In this chapter, we have covered the following in detail: need for object-oriented programming, procedural languages, the object-oriented approach, advantages of object-oriented programming, characteristics of object-oriented languages, objects, classes, inheritance, reusability, new data types, polymorphism, and overloading.